Hello my dear students, I am Deepak Vanjani. Let us continue with chapter number 2, Electrostatic Potential and Capacitance. Last time we have studied about parallel plate capacitor. Today we will study about spherical capacitor. So let us start with the topic spherical capacitor. Here also I have taken two conductors. This is the first conductor, that is the spherical conductor having radius A, and this is second conductor having radius B. As I told you, if charge on first sphere is plus q, if charge on one of the conductor is plus q, then charge on second conductor should be minus q, because we know the total charge of the capacitor, that is 0. So here charge on first conductor, that is plus q, and charge on second conductor, that is minus q. Here we know that electric field inside the conductor is 0, therefore electric field inside the spherical shell of radius A, that is 0, and whenever charge is given to the conductor, it lies on the surface of conductor, therefore this positive charge lies on the surface of conductor. Now this first sphere is of radius A, so radius of inner sphere is equal to A, and radius of sphere, outer sphere, radius of outer sphere is equal to B. Here electric field between these two conductors, it means in the gap of these two conductors, that is outer sphere and inner sphere, is only because of positive charge, not due to this negative charge, because electric field inside the conductor is 0. Due to this charge there won't be any electric field inside the conductor, therefore electric field is only because of positive charge, and we know that electric field due to positive charge is from positive to negative, or you can say electric field due to positive charge is away from the charge. So here you can see electric field lines are away from the charge. Now these two conductors, whenever any two conductors are insulated from each other, at the time they will form capacitor. So capacitor is nothing but whenever two conductors are insulated from each other, then capacitor is formed. So this capacitor is called spherical capacitor because its shape is spherical, therefore it is called spherical capacitor. Right now insulating medium I am considering vacuum. Now if I consider one Gaussian surface which I have shown with blue dotted line, this is nothing but Gaussian sphere, and if I want to find electric flux associated with this Gaussian surface, then we know the formula of electric flux. Electric flux is nothing but electric field into area. So electric field, that is E into area of sphere. For this Gaussian surface I am taking radius r, so 4 pi r square into E. 4 pi r square, that is the area, and E, that is electric field. And electric flux for any closed surface, electric flux for Gaussian surface is nothing but charge enclosed upon epsilon naught. What amount of charge is enclosed by the Gaussian surface? Charge enclosed is nothing but plus q, so we can write plus q upon epsilon naught. Therefore electric field E is equal to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught into q upon r square. Therefore in vector form, if we want electric field, then E vector is equal to, what is the direction of electric field? Electric field, that is radially outward. So we can write 1 upon 4 pi epsilon naught into q upon r square into r cap, because electric field is in radial direction, therefore we can take r cap. Unit vector I have taken r cap. Let me find potential difference between these two conductors. So potential difference between these two conductors, here on sphere of radius a there is positive charge, so this potential will be more than this, because on this sphere potential that is negative. Therefore we can take potential difference VA minus VB. So potential difference I am taking V is equal to VA minus VB, but we know the formula of potential difference. Potential difference is nothing but minus integration of E vector dot dr vector. VA minus VB is equal to minus इंटीग्रेशन E वेक्टर डॉट dr वेक्टर. ये फॉर्मूला हम पढ़ चुके हैं जब मैंने आपको इलेक्ट्रोस्टैटिक पोटेंशियल पढ़ाया था, तब हमने ये फॉर्मूला ऑब्टेन किया था. VA माइनस VB पोटेंशियल डिफरेंस इज नथिंग बट माइनस इंटीग्रेशन ऑफ E वेक्टर डॉट dr वेक्टर एंड लिमिट विल बी फ्रॉम सेकंड टू फर्स्ट B टू A. अगर हम VB माइनस VA लेते तो लिमिट क्या हो जाती? A टू B. Here we have taken VA minus VB, therefore VA minus VB is equal to integration E vector dot dr vector, limit is from B to A. Value of E vector is available to us. What is E vector? 1 upon 4 pi epsilon naught into Q upon R square into R cap. So 1 upon 4 pi epsilon naught Q upon R square into R cap dot this dr vector, that is displacement. Dr is also radial, so dr into r cap. Here this is the integration with respect to r. This is the integration with respect to r. Therefore we can take q upon 4 pi epsilon naught outside the integration, so it can be written as is equal to minus q upon 4 pi epsilon naught integration b to a 1 upon r square dr. What about r cap dot r cap? We know that I cap dot I cap is equal to 1, j cap dot j cap is equal to 1, k cap dot k cap is equal to 1. Same way r cap dot r cap is equal to 1. This thing already we have studied in standard 11. Now this is the integration with respect to r, and we know the integration of 1 upon r square. What is the integration of 1 upon r square? Minus q upon 4 pi epsilon naught as it is, integration of 1 upon r square, that is minus 1 by r, minus 1 by r, and limit is from b to a. Correct? Minus minus plus q upon 4 pi epsilon naught as it is, minus minus plus, therefore we can write 1 upon r b to a. Now we have to substitute the limit. Q upon 4 pi epsilon naught as it is, first limit 1 upon a minus 1 upon b. This is the potential difference. Now if we take the LCM, then V is equal to Q upon 4 pi epsilon naught into b minus a upon a into b. So this is the potential difference, Q upon 4 pi epsilon naught into b minus a upon ab. Therefore now we are interested in capacitance of the spherical capacitor, and we know the formula of capacitance. What is the formula of capacitance? Capacitance is nothing but that is the ratio of magnitude of either charge to the potential difference. So magnitude of either charge on the conductor, that is q, upon potential difference that we have already obtained, that is v. So C is equal to q by v. So if we take the ratio q by v, then q by v can be written as 4 pi epsilon naught ab upon b minus a. Once again, if we take v on this side, then q by v is equal to 4 pi epsilon naught ab upon b minus a. So formula of capacitance of spherical capacitor is 4 pi epsilon naught into radius of inner sphere into radius of outer sphere upon radius of outer sphere minus radius of inner sphere. This is the formula of capacitance of spherical capacitor. This way we can obtain the formula of capacitance. Now if we think of only one spherical conductor, then we can take this B to be at infinity. It means if we consider this second sphere to be very large, and if radius of the second sphere is very large in comparison to A, if it tends to infinity, then this value of B will be very large and A is very small in comparison to B. Therefore, we can neglect A in comparison to B. B will get cancelled. When B tends to infinity, at that time B is very large in comparison to A. So, we can neglect A in comparison to B. So, 4 pi epsilon naught A, B will get cancelled. So, formula of capacitance will be 4 pi epsilon naught A. When we are considering only one spherical conductor, at that time we can use this formula. Because when we are considering only one spherical conductor, at that time we take second spherical conductor to be at infinity. So, C is equal to 4 pi epsilon naught A. This is the formula for spherical capacitor when B tends to infinity. So, C is equal to 4 pi epsilon naught A. Let me take one example of spherical capacitor. If we take A is equal to 1 millimeter, this radius of inner sphere is equal to 1 millimeter and B is equal to infinity, then the formula of capacitance is nothing but 4 pi epsilon naught A, 4 pi epsilon naught into radius of sphere, that is A. But we know the value of 4 pi epsilon naught. 1 upon 4 pi epsilon naught, that is nothing but 9 into 10 raised to 9. 9 into 10 raised to 9. What is the unit of 1 upon 4 pi epsilon naught? That is Newton meter square per coulomb square. So, if 1 upon 4 pi epsilon naught is 9 into 10 raised to 9, then 4 pi epsilon naught is nothing but 1 upon 9 into 10 raised to 9. And what is A? 1 millimeter. Milli is nothing but 10 raised to minus 3. So, 10 raised to minus 3 upon 9 into 10 raised to 9. 1 upon 9, that is 0.11. Minus 3 minus 9, that is minus 12. So, the answer will be 0.11 into 10 raised to minus 12 farad. 10 raised to minus 12 is denoted by pico. So, 0.11 picofarad. When we take A is equal to 1 millimeter and B infinity, then capacitance of that spherical capacitor will be 0.11 picofarad. Now, if we consider very large conducting sphere, it means if we want to find capacitance of earth and assume the earth to be spherical, if we consider earth to be spherical, then we can find the capacitance of earth. Whenever we consider only one single spherical conductor, at that time the formula is 4 pi epsilon naught into A. What is A? That is the radius of the spherical conductor. Radius of earth, that is 6400 km, and formula for spherical capacitor is 4 pi epsilon naught R. When we consider only single spherical conductor, at that time we can write value of radius R, that is nothing but 6400. Convert kilometer into meter, then 6400 into 10 raised to 3. 4 pi epsilon naught. Right now I told you 4 pi epsilon naught is nothing but 1 upon 9 into 10 raised to 9. So 1 upon 9 into 10 raised to 9. 6400 upon 9, that is 711.11. 10 raised to 3 minus 9. 10 raised to 3 minus 9, that is 10 raised to minus 6 farad. But 10 raised to minus 6 is denoted by micro. So, if we consider a very large spherical conductor, that is of the size of earth, then the capacitance will be 711 microfarad. Nearly for very large spherical conductor having same as the size of earth, for that capacitance will be few hundred microfarad. It means farad is very large unit of capacitance. And capacitances are of the order of microfarad, picofarad and nanofarad. So farad is very large unit of capacitance. Here I think now the concept of spherical capacitor is clear to you. Now we will study cylindrical capacitor. Next topic, that is cylindrical capacitor. The way we have obtained the formula of capacitance for spherical capacitor, same way we are going to obtain formula of capacitance for cylindrical capacitor. Here I have taken two cylinders. This is first cylinder which is positively charged and this outer cylinder that is negatively charged. Radius of cross section of first cylinder, that is A, and radius of cross section of second cylinder, that is B. Here equal and opposite charges are there on this first and second cylinder, and this is cross sectional view of this cylindrical capacitor. If we observe the cross sectional view, then for this cylinder that is positively charged and this is negatively charged, and electric field lines due to these positive charges are away from positive charge and they are radial. Here length of this cylinder is very much greater than this radius of cross section A and B. When this length is very large in comparison to A and B, then we can think of uniformly charged infinitely long wire. That is nothing but first application of Gauss's law, and that already we have studied in chapter number 1. What is the formula of electric field due to uniformly charged infinitely long wire? That is E is equal to lambda upon 2 pi epsilon naught R. Okay. Where lambda, that is linear charge density, and here I am taking one Gaussian surface. That Gaussian surface I have shown with a blue color. So this is the Gaussian surface, and this Gaussian surface encloses some charge, and we know the formula of electric flux. Electric flux phi is equal to charge enclosed upon epsilon naught. Therefore charge enclosed is equal to lambda L, and electric flux associated with this Gaussian surface is charge enclosed upon epsilon naught, that is lambda L upon epsilon naught. But we know the formula of electric flux, that is electric field into area. Electric field, that is E into area of the cylinder, that is 2 pi R L. L will get cancelled. Therefore electric field E is equal to lambda upon 2 pi epsilon naught R. In vector form we can write E vector is equal to lambda upon 2 pi epsilon naught R into R cap. Why? Because electric field, that is radial, at any point if you consider, suppose this is the cylinder that is positively charged, then electric field at each and every point that is radially outward. Therefore we can write E vector is equal to lambda upon 2 pi epsilon naught R into R cap. Because the electric field is in radial direction, we can take unit vector as R cap. Now we have to find potential difference. Potential difference, V is equal to VA minus VB, and for potential difference the formula is integration E vector dot dr vector. Limit is from B to A, final to initial, B to A, E vector dot dr vector. Now what is the value of E vector? E vector, that is nothing but lambda upon 2 pi epsilon naught R into R cap. So lambda upon 2 pi epsilon naught R into R cap as it is, into dr vector. Dr, that is displacement, that is also radial, dr into R cap. because it is from A to B. Now here this is the integration with respect to r, therefore we can take lambda upon 2 pi epsilon naught outside the integration, minus as it is lambda upon 2 pi epsilon naught outside the integration b to a as it is 1 upon r dr, r cap dot r cap, that is nothing but 1. Now here this term can be written as is equal to lambda upon 2 pi epsilon naught integration a to b 1 upon r dr. अब आप बोलोगे सर माइनस कहाँ चला गया? Here when we remove minus, at that time limit will change. Here the limit is from b to a, and when we remove the negative sign, at that time we have to change the limit, that is from a to b 1 upon r dr. Okay, lambda upon 2 pi epsilon naught 1 upon r dr. What is the integration of 1 upon r dr? That is ln r. So ln r a to b, limit is from a to b. Substitute the limit, lambda upon 2 pi epsilon naught as it is ln b minus ln a. Log minus log, that is ratio. So lambda upon 2 pi epsilon naught ln b by a. So potential difference between two conductors is lambda upon 2 pi epsilon naught ln b by a. Once potential difference is available, we can find capacitance. What is the formula of capacitance? C is equal to Q by V. Formula of potential difference between two cylindrical conductors is lambda upon 2 pi epsilon naught into ln b by a. Potential difference is available to us and we are interested in capacitance. But capacitance is equal to Q by V, and we know the relation between lambda and Q. Charge Q is equal to lambda L, therefore lambda is equal to Q by L. So instead of lambda we can substitute Q by L. Therefore potential difference V is equal to, instead of lambda I have taken Q by L, 2 pi epsilon naught as it is ln b by a. Now capacitance C is equal to Q by V. So Q by V is equal to 2 pi epsilon naught L upon ln b by a. Q by V 2 pi epsilon naught L upon ln b by a. But what is Q by V? Charge upon potential difference, that is nothing but capacitance. Therefore C is equal to 2 pi epsilon naught L upon ln b by a. This is the formula of capacitance of cylindrical capacitor. What is the formula of capacitance of cylindrical capacitor? 2 pi epsilon naught L, that is length of cylinder, upon ln, that is radius of cross section of outer cylinder, upon radius of cross section of inner cylinder, b by a. Now if we want to find capacitance per unit length, then capacitance per unit length, that is C by L. So C by L is nothing but 2 pi epsilon naught upon ln b by a. This is capacitance per unit length, and this is capacitance of cylindrical capacitor. Capacitance of cylindrical capacitor. You should remember this formula of capacitance of cylindrical capacitor and capacitance of spherical capacitor. Using this formula you can solve numericals and MCQs. I hope the concept of spherical capacitor and cylindrical capacitor is clear to you. We can take any arbitrarily shaped conductors to form capacitor and we can obtain the formula of capacitance. Please remember the formula of capacitance of cylindrical capacitor and capacitance of spherical capacitor. Thank you.